My name is Ashish Kumar. I am an assistant professor, Department of Computer Science and Engineering, Ajay Kumar Garg, Engineering College, Ghaziabad. My subject is Artificial Intelligence and subject code is KCS 071. And today is my third lecture. My third lecture topic is forward chaining and backward chaining in AI. Okay. So I move on the next next slides. So here, before starting the forward chaining and backward chaining, first know about the inference engine. What is the inference engine? The inference engine is the component of the intelligent system in artificial intelligence which applies logical rules to the knowledge base to infer new information from known facts. The first inference engine was part of the expert system. Inference engine commonly proceeds in two modes, which are first is forward chaining, another is backward chaining. First, what is the inference engine? Inference engine basically knowledge plus rules, add some rules, and finally find conclusion. That means ki in a inference engine, I collect to some information, different information from different places, and add some adding some information related different information, and create the some conclusion. That is here mentioned already. Collect the knowledge and add some rules, and finally move on conclusion. Basically, inference engine commonly proceed in two modes, which are forward chaining and backward chaining. That means forward chain. What is the forward chaining and what is the backward chaining? Initially, move on the forward chaining. What is forward chaining first? What is forward chaining? Forward chaining basically given some data, and add some rules, and go for the conclusion, just as inference engine. Okay. So I've taken one simple example. Before one simple example, I've just see the exact definition. What is the forward chaining? Forward chaining is also known as the forward deduction or forward reasoning method when using an inference engine. Forward chaining is a form of reasoning which start with atomic sentences in the knowledge base and apply the inference rules in the forward direction to extract more data until a goal is reached. That means in a forward chaining, I have to collect the knowledge and add some rules and logics on that knowledge and provide some new conclusion. That is called the forward chaining. Already discussed, in a forward chaining case, some data is given, give data plus add some rules and then find conclusion. So I have take here one simple example related to forward chaining. First, suppose a given data is 2 and y is equal to 2. It is a data part, and add some rules, that means some conditions. If x is equal to 2 and y is equal to 3, here take 3, then z is equal to 4. Okay. Again, next condition is if z is equal to 4, then a is equal to 4. Finally, conclusion what? A is equal to 4. It is a very small example related to the forward chaining, but in exam point of view, you have to see some more example. So here I'll discuss all some example. Before discussing some more example, I see the properties of the forward chaining. It is a down-up approach as it moves from bottom to up. It is a process of making a conclusion based on known fact or data. By starting from the initial state and reach the goal state, forward chaining approach is also called a data driven. Why data driven? Because data rules are given and data values are already given. So it is also called a data driven. As we reach to the goal using available data, forwarding chaining approach is commonly used in the expert systems such as the CLIPS, business and production rule system. Basically, forward chaining basically used in a business, production rules and CLIPS, because in a production, business and CLIPS, it is follow some initial state to goal state. Because in a production part, first up manufacturing some manufacture some equipments and finally reach the goal and finally reach a goal. That is a part of the forward chaining goal. That means that is a part of the forward chaining. So here I take the one more example. It's a most important example. The example here mentioned. It is a most important example in a point of the university exams and other competitive exams. Some of the books are already this example uses. So here I discussed one by one steps in that example related. In this example, I have to discuss about the tree, how to generate the tree using this example. So example is here. The law says that it is a crime for an American to sell weapon to hostile nation. The country no, an enemy America has some missiles and all of its missiles were sold to it by Colin West. Who is an American? Prove that Colin West is a American. Here some sentences are used here. First sentence is some person who are selling the weapon to hostile nation is a crime in America. So in that statement are uses so create the facts and then create the logic. So in next slide I have to discuss some facts and logic. Here some facts is it is a crime for an American to sell weapon to hostile nation. That is the main factor. It is a crime activities in America. Some person selling the weapons for the hostile nation. So here this data steps as a user the some facts, and using that facts I have to create the some logics. So first I have to check the statements. In that statement I have used the some terms. First is American, next is weapon, next sale, next is hostile, and then crime. But America first, that is America is coming first. So it is a seller is a weapon and then sales and hostile nation, and that is a criminal. So here create a logic. What logic? That is the first is American. American it is denoted to the variable X, and next is weapon. Weapon denoted to the variable Y, and sales X, Y, Z. X is the American, sales, weapon, or Z is my hostile. Hostile here mentioned. And final conclusion is that person is say that the criminal. That means the criminal is X. Here some variables are using the X form. And another statement here, Nono has some missile. That means Nono some missiles are there. It is represented not in that forms in Nono missile, because this statement is wrong. So here mention as a user own has some statement are here uses. So here statement using the own Nono's X, X is here missiles, that is already mentioned. X is a missiles, and because X is already variable already used in American X, so here missile is denoted through the variable of M1. And another statement is say that all of its missiles were sold to by colon based. Colon based is a person that is selling some missiles enemy states, countries. So here all of its missiles were sold to it by colon based. So that statement, using that statement, write down some logic. So first is missiles, owns no X some missiles, and seller is west, colon based, sell missile to no. How to pronounce this statement? First, colon based, sells weapon no. That statement is in this way we have to use it. And next, last line is missiles are weapon, that is missiles is weapons. This statements, using of this statement, I have to create, and another other statement are also mentioned here. So an enemy of American counts as the hostile. That means enemy is the basically terrorist part of the American. So it is denoted to the enemy. So enemy X is the American, X is the my hostile, and colon based who is an American. Colon based is a American. That means American is a colon based. Here mentioned already. And the country no an enemy of America. So no is a country that is a enemy of America. So enemy no America. That means no is the enemy and America. So that statements are used one by one using for the tree. My main motive is the proof that the colon based is criminal. So here through tree I have to use some statements and some notes, and finally describe the proof that the colon based is a criminal. So using in a fact forms, right side is my fact statements, right part is my right, in every left part is my fact statement. So here first use some lefts. So some first left is enemy no American colon based is my left section of the every statement. Enemy X is the Americans, and here missiles X and own nanos M1 and American S. This statement using in a node form in my examples. I'm in a tree. So first here mention enemy America. First is mentioned that is a part of the no American. It is left side part are used as a fact form. So first enemy no American, then American colon based here uses colon based, and next is left side is my own no M1. Missiles X. So missiles is denoted through the M1, and another is own nonos because missiles is already uses here. So and owns nonos are mentioned. So every nodes are using in as a graph form. So here display. So after using that nodes, I have to move on the right side of the every nodes. That means this is a root nodes, and I have to check the every right nodes, and every right nodes if related to the root nodes, then put on this tree. So first if the enemy no American is no any right nodes, American colon based is no any right nodes, but here enemy no American, that is a hostile X is the my right nodes. Right node is a hostile X, and it is a root node. A root node is mentioned in my tree. So hostiles X is a put on a tree here. Yeah, oxtribe is a put here. So another I have to check in a cell based X nano is the part of the missiles and owns. Adding the missiles and owns, cells based nano is the part of the owns and missiles. Both are present in a root node. So here mention missiles using this and this. Okay. Another part is already here missile weapons. Weapons is the right nodes of missiles. So missiles is the root node. So weapons already mentioned here. So after this completed this section at this level, so move on the next level. Next statement is finally is my criminal. Criminal is my final statement, and final statement I have to check the left side all hostile is already mentioned in the my tree, and sales part is also mentioned in my tree, and weapon is and American, all roots are measured in the tree. So all after the adding the all of you, I have to finally prove that that is a criminal. So finally I have to prove it is a criminal. That means American is a criminal. It is finally proved using the forward chaining. Forward chaining move on the top down approach, and bottom up approach it is a, so here move and bottom to up approach are using here. So next is efficient of forward chaining. Order conjuncts appropriately. Example, most concurrent variable do not generate redundant facts. Each new facts should dependent on at least one newly generated facts. Production system RT matching clips into the part of the efficient of forward chaining. Another in a forward chaining case, another is a backward chaining. Backward chaining, before starting the backward chaining, all of you know that the backward chaining, it is also part of the inference engine, and in that case goal state is given, then move to initial state. That is already used in a DFS. You have already used in DFS initial state, because in a DFS I have to use the backtracking and forward tracking already used in a DFS form. So first in a backtracking backward chaining is a goal state is the given, and move on the initial state. I have to check some example. So first I have to see the main definition of the forward to backward chaining. Considering the items to prove in a goal, find a rule whose head is goal, and binding, apply binding to the body and prove this in turn. If you prove all the sub goals including a binding set as you go, you will prove the item logic programming C prologue on CS. That is, you say that the goal state to move to the final state, it is called the backward chaining. Same example here I have to use. Before example, I have to check some properties of the backward chaining. It is known as the top-down approach. Backward chaining is based on the top-down approach. That means goal state is my top state, so I have to move on the initial state. Backward chaining is based on modes of Bonham's inference rules. It is use the inference rules. In inference rules, some add some features, given knowledge, and find the new information, generate the new information, and finally find the conclusion. In backward chaining, the goal is broken into sub goal or sub goal to prove the fact rules. It is called goal driven approach, as it's a list of goal decides which rules are selected and used. Backward chaining algorithm is used in a game theory, automata, theorem, providing tools, inference engine, proof assistant, and various AI application. Backward chaining method mostly used in the depth first search. I have to already in depth first search backward tracking, because in a depth first search you move from the top to bottom approach. Then I have to move leaf node, but my goal node is not found. Then I have to take some backtracking, and then after backtracking, then I have to move on the goal side. Okay. So here some example mention automated Thurman provisioning tools, inference engine, proof assistants, and various AI application are using the backward chaining, because in that case you have to use forward and backward goals. So take one example. Already that example I have to discuss here. So my example is x is equal to 2, y is equal to 3, and add some rules. First you see the forward example. So condition here mention x is equal to 2 and y is equal to 3. So then z is equal to 4 is my statement. If condition again arise and z is equal to 4 and my a value is, then a value is 5. So final conclusion is find out 5 already 5. That example already discussed in a forward chaining. So in a forward chaining, but in forward chaining I have to move from the given data to the conclusion, but in a backward chaining first you have to check the goals. The goal is here a is equal to 5. So first I move the a is equal to 5, then I have to move in that condition, then I move that condition, sub goals, and then finally I have reached the initial state. It is a very smallest example. So example point of view, we have to see on another example, same example are using here, using criminal based example. So I have to in a forward chaining, you have to see that the starting from the left one side, but in backward chaining you have to starting the right one side. So first my goal is criminal west is my colon west is a criminal, it is my goal. Before another first move and another slides, in that slides criminal x is my right side, and some notes are another values and another statements related to the criminals. So criminal is my root nodes, and related to left, first you check the left values, and all left values put on the my tree. So here all values are puts, every values inputs here, either American, sales, hostile, all values are put under here. So again I have to check another right statement value, because right statement is my the root nodes, then I have to check the left statement, that left statement related to the my root nodes, then put on the my tree. So here I have to check some statements. Some statement is there. So missiles is related to the own nonos, and another right is hostile is already here mentioned. So it is put on the root nodes and my tree. So and another cell west x nono is already cell x, because x y z is using the 3 variables, and here all the cells are using 3 variables. Cells is the part of the new my root nodes, then own and x missiles is already put in the my tree. So in this way I have to put this is the part of the criminal based, the left statements. Then again American, after American no any left statement is there, that is the true value. Then I have to check weapon, left side is given here missiles, and sales is a no, that is the backward directions, and another hostiles part of the enemy of nonos. So finally after this no any statement are there, so it is my true state, and it is also called a true state, because in that statement no any another statement is available, so it is reached my final state. So that is all of true state. So finally it is proved that the backward chaining from goal nodes to last nodes. Some another information or adding the slide is related to the semantic networks. What is the semantic network? It is related to the another link statements. In a 1909, Charles S. Bries proposed a graphical notation of nodes and edges called extensional graph. A typical graphical notation display object or category names in oval or boxes and connected with labeled arcs links. For examples, first, what is the semantic network? Semantic network basically logic are given, and that through the logics you have to create some graph and some tree, that is called the semantic network. Some here using some examples. That example, member of link between Mary and female person corresponding to the logical assertion. Mary is a part of the female person. Sister of link between Mary and John corresponding to the assertion. Sister of Mary and John connected category using the subset of the links. So it is my example how to represent it in the graphical form. In the graphical form, first here represented here. So first denoted to the Mary, it is taken a Mary. Then I have to check the John. because in the example you have to already mention Mary is related to the female parts, so Mary is related to the female, and John is a part of the male persons, and it is the also subset of the persons, and it is also a subset of the person. Finally, all is it is a part of the semantic network. In that network, you have to represent the some statement in the form of the tree and graphs. So here a semantic network with the 4 objects, John, Mary, and 1 and 2, and 4 categories relations be denoted to the labeled links. Another laws of inheritance reasoning. Female person inherited the properties from the person. Mary inherited the property having 2 legs. The simplicity here also mention legs. Here not discussed here. John have 1 legs. Okay, John have 1 legs there. So yes, John have 1 legs here. Female person inherit the all properties from person. Marries the property having 2 legs. The simplicity efficiency of the inference mechanism compared with the logical theorem has been one of the main attraction of the semantic network. Multiple inheritance becomes complicated because 2 or more conflicting values for answering the query. For this reason, multiple inheritance is a banned in some object-oriented programming language such as Java. In a Java and some object C++, already you have to concept of the inherited. Already know that the inherited, that means the take the properties of the another classes. So here also some properties are mentioned and some properties are there to the classes. So inherited.